Imagine I walk up to you and ask a very simple question. What is happening right now? You might say, well, I'm watching this video. Simple enough. It feels like an obvious question with an obvious answer, but physicists have a nasty habit of taking obvious questions and stretching them until they break. So let me make the question a little more uncomfortable. What is happening right now on the other side of the universe? Your first instinct might be to laugh and say, how should I know? And that's actually a very good answer. Because the strange truth is that physics itself may not know either. We grow up believing something that feels completely natural, that the universe has a shared present moment. Somewhere billions of light years away, stars are exploding right now while you're listening to this. Civilizations may be rising or falling right now. Galaxies may be colliding right now. It feels like there is one universal clock ticking for everything. But modern physics suggests that this idea, the idea of a universal now, might be an illusion. And if that sounds bizarre, let me show you how we got there. Let's begin with something simple.
Imagine you're standing on a railway platform. A long train rushes past you at incredible speed. Suddenly, two lightning bolts strike the train, one at the front and one at the back.
You happen to be standing exactly in the middle. The flashes reach your eyes at the same time, so naturally you say, those two lightning strikes happened simultaneously. Seems perfectly reasonable. Now imagine a passenger sitting exactly in the middle of the train, but remember, the train is moving very fast. Because she is moving toward the light from one strike and away from the other, the light from the front reaches her first, and the light from the back reaches her later. So she concludes something different. The front lightning strike happened before the rear one.
Now here is the strange part.
Neither of you is wrong. According to the theory developed by Albert Einstein, simultaneity depends on your state of motion. Two people moving differently through space can honestly disagree about whether two events happened at the same time, and both measurements are valid. That idea alone is already strange enough to make most people pause. But the real shock comes when you follow the logic all the way through. If different observers disagree about which events are simultaneous, then the universe cannot have a single shared present moment. There is no cosmic clock telling everyone in the universe what time it is. Instead, every observer carries their own slice of time. Think about that carefully. If two people moving differently disagree about which events belong to now, then the idea of a universal present collapses. And once that idea collapses, something astonishing emerges. It suggests that the past, present, and future might all exist together. To understand what physicists mean by this, imagine a loaf of bread. Each slice of bread represents a moment in time. One slice might represent the year you were born. Another slice might represent today. Another slice might represent something that will happen 100 years from now. In everyday thinking, we imagine that the loaf hasn't been cut yet. We think the universe is slowly creating new slices as time passes. But relativity suggests something different. It suggests that the entire loaf might already exist.
Different observers simply cut through it at different angles.
This picture is sometimes called the block universe. In the block universe view, the universe isn't something that unfolds moment by moment like a story being written. Instead, it's more like a giant four-dimensional structure, space and time woven together into a single fabric called spacetime.
Every event that has ever happened or will ever happen occupies a position in that structure.
Your childhood exists there. This moment exists there. Your future exists there. They're simply located at different coordinates in space-time. Now, before you panic and think this means everything is predetermined and nothing you do matters, hold that thought. We'll come back to that later. For now, let's focus on something even stranger. If the past and future are part of the same space-time structure as the present, why does time feel like it's flowing? Why do we feel like we're moving from yesterday into tomorrow? Why do we remember the past but not the future? To understand this, we need to look at the laws of physics themselves. One of the most surprising discoveries in physics is that the fundamental equations describing nature don't care about the direction of time.
Take Newton's laws of motion.
If you record two billiard balls colliding and play the video forward, the motion obeys Newton's laws perfectly. Now play the video backward. The motion still obeys Newton's laws. From the perspective of the equations, both directions are allowed. The same is true for many other fundamental laws: electromagnetism, quantum mechanics, and even Einstein's equations of gravity mostly work the same way forward and backward in time. In other words, the basic rules of the universe don't contain a built-in arrow pointing from past to future. So if the laws of physics don't care about the direction of time, why does the world around us clearly move in one direction? Eggs break, but they never unbreak. Ice melts, but puddles don't spontaneously freeze into perfect ice cubes on warm pavement. Smoke spreads through the air but never gathers itself back into a cigarette. The key to this mystery lies in a concept called entropy. Entropy is one of those words that physicists love and everyone else finds confusing. So let's make it simple. Imagine you have a box filled with tiny gas molecules. Suppose all the molecules start out bunched together in one corner of the box. That arrangement is very orderly. There are only a few ways to place all the molecules in one corner. Now remove the barrier and let them move freely.
Over time, the molecules spread out until they fill the entire box.
Why does this happen? Because there are vastly more ways for molecules to be spread out randomly than to be neatly packed into one corner. The spread out state has higher entropy. The bunched up state has lower entropy. Given enough time, systems almost always move from low entropy to high entropy simply because there are more possible arrangements that look disordered than ordered. This statistical tendency creates what we call the arrow of time, and it applies to everything.
A neat stack of papers on your desk can easily become messy, but a messy pile rarely organizes itself into a neat stack by accident.
A shattered glass could theoretically reassemble itself if every atom moved exactly the right way, but the number of arrangements corresponding to shattered glass is astronomically larger than the arrangements corresponding to perfect glass. So disorder wins again and again. Now here's the crucial point. The laws of physics themselves do not force entropy to increase. They simply allow many possible arrangements. But our universe started in an extremely special low entropy state near the beginning of cosmic history. Since then, entropy has been increasing.
The arrow of time we experience, the direction from past to future, is essentially the direction in which entropy increases.
That's why we remember the past but not the future. Memories are physical records stored in your brain. Creating those records increases entropy. So memories always point toward the low entropy past. Your brain literally builds records of earlier states of the world. And because those records accumulate over time, it feels like time is flowing. But the feeling might be misleading. Your brain is constantly receiving signals from your eyes, ears, and other senses. These signals arrive at slightly different times, sometimes milliseconds apart. Your brain processes them, organizes them, and constructs what it calls the present moment. In reality, what you experience as now is a carefully assembled summary of events that actually occurred a fraction of a second ago. Your brain is essentially running a tiny simulation of the world, and inside that simulation, it feels like time is passing. Now let's pause for a moment, because at this point, many people start to feel uneasy. If the future already exists somewhere in space-time, does that mean the future is fixed?
Are we just characters in a pre-written cosmic script?
This is a common worry, but it comes from misunderstanding the block universe picture. Imagine reading a novel. All the pages already exist from beginning to end. The story is fixed on paper, but inside the story, the characters still make choices. Their decisions shape what happens next, within the narrative. Similarly, in the block universe, your choices are part of the structure of space-time.
Your decisions are not outside the universe, they are events inside it. The moment you decide to change careers, call a friend, or take a different path home is just as much a part of the space-time structure as a star exploding in a distant galaxy.
Your actions matter because they are woven into the fabric of the universe itself. Another way to think about this is to imagine a map. On a map, New York, Los Angeles, and Chicago all exist at the same time on the page. But if you're traveling across the country, you experience those cities one after another. The entire map exists simultaneously, but your journey gives you the experience of moving through it. Time might work in a similar way. All moments exist in the structure of space-time, but conscious beings like us experience them sequentially. And that experience creates the sensation of a flowing present.
But physics goes even further. When scientists attempt to combine quantum mechanics with gravity, something we still don't fully understand, they sometimes encounter equations where time disappears entirely.
One famous example is the Wheeler-DeWitt equation in quantum gravity. Unlike most equations in physics, it contains no explicit time variable. In a sense, it describes the universe as a timeless object. This has led some physicists to propose a radical idea that time is not a fundamental ingredient of reality at all.
Instead, time may emerge from relationships between parts of the universe. Just as temperature emerges from the motion of molecules, even though individual molecules don't have a temperature, time might emerge from the complex interactions between physical systems.
In other words, the universe at its deepest level might simply be. Not evolving moment by moment, just existing as a vast network of events and relationships, and the passage of time might be what that structure feels like from the inside to conscious observers. If that sounds strange, consider this. When you look at the night sky, you are already looking into the past. The light from the moon takes about a second to reach you. The light from the sun takes about 8 minutes. The light from distant stars may have traveled for hundreds or thousands of years before entering your eyes. Some galaxies we observe today are billions of light years away, meaning the light we see left them billions of years ago. In a very real sense, the universe we observe is a mosaic of different times. Astronomy is not just the study of distant objects, it's the study of distant moments in history.
And yet we experience all those signals together as a single present.
Your brain gathers ancient photons from distant stars and fresh photons from nearby objects and blends them into one coherent scene.
That scene feels like now. But it's actually a mixture of events that occurred at very different times. The deeper we look into the universe, the more we realize that our everyday intuitions about time are surprisingly unreliable. And yet, despite all this strangeness, our experience of time remains meaningful. We still make plans. We still feel nostalgia. We still hope for the future. Even if the universe is a four-dimensional structure where all events exist, we are creatures who experience that structure locally, moment by moment. Our memories, expectations, and decisions are part of the pattern. The experience of time is what allows us to navigate the world. It's the interface between consciousness and the deeper laws of physics. Think of it like the interface of a computer. When you move files into folders on your desktop, you're not actually moving tiny documents through space. The computer's hardware is performing complex operations at the level of electrical circuits. The desktop interface is just a simplified way for your mind to interact with that complexity. Time might function similarly. The flow of time might be the brain's user interface for navigating the deeper structure of space-time. And if that's true, then the ticking of the clock on your wall is not the universe marching forward.
It's simply one of many ways humans measure change.
Which brings us back to where we started.
What is happening right now on the other side of the universe?
The honest answer may be it depends on who you ask, how they're moving, and how they slice through space-time. There may not be a single answer, and perhaps that's the most beautiful part of this whole story. The universe is far stranger than the simple clockwork picture we once imagined.
Time may not flow the way we think.
The past might not truly be gone. The future might already be woven into the structure of space-time, and we, tiny conscious beings on a small planet orbiting an ordinary star, have somehow evolved the ability to glimpse these deep truths. The next time you look at a clock and see the seconds ticking away, remember something remarkable. That ticking might not represent the universe moving forward.
It might represent your mind traveling through one tiny path in a vast cosmic structure.
A structure that contains every star that has ever burned,
Every moment that has ever been lived.
and perhaps every moment that ever will be.